Welcome back, engineers. We are discussing common techniques and algorithms in system design, and in this video, let's look at geohashing. I hope you're ready. Let's get started. So, we have seen this question before, proximity search, when we have discussed quadries, right? So, we have a point from which we want to locate nearby stuff, right? It could be nearby restaurant, nearby drivers, riders, whatever it may be, but we want to locate nearby stuff on a geospatial region, right? So let's say in this case we have a point here and we want to get nearby points within x radius. In this case, let's say it is 2 kilometers. So we have already seen a solution for this. It was using quadries, where we divided a region into 4 quadrants and we subdivided recursively in each quadrant until we get to a granularity that we need, right? So that was one approach, and this is the second approach using geohash. So in this video, let's try to understand what is geohash, how it's effective in dividing a two-dimensional space into subcomponents, and see how we can actually leverage it in our system design, right? So let's see. So the geohash system works something like this, right? So let's say we have a world map and it has been laid out on a two-dimensional space, right? So geohash works in levels. So in first level, we divide the entire world map into 32 regions, right? So like this, we divide it into 4 by 8 grid, which is 32 cells basically, and we assign each cell an individual character, right? And in level 1, we are adding one character. So this is level 1. And as we go deeper into the levels, we are actually kind of zooming into the world map, right? For example, if we take this block number 1 and then we go into level 2 into that block, we are essentially zooming into that block, right? So in this case, we are getting another 32 blocks. So this is another 4 by 8 grid, and you can see that we are adding one more character, making it a total of 2 characters. So the deeper we go, the more characters we add, and the more characters we add, the deeper we are into the zoom levels of the world map, right? It is that simple. Now we are at level 2, and if you look at the numbers inside the grid, so this is an alphanumeric string, okay? So what we are doing is we have a prefix of 1 everywhere, right? So the 1 is coming from the previous higher level, and we are just adding another character based on a calculation about converting a lat long or a region into geohash strings, right? So let's say we are again getting a 4 by 8 grid, and we are now wanting to zoom in further into one particular region. Let's pick 1H as our region now, and then we go deeper into it, and we are adding 3 characters now. So again, we went one level deeper, which means we have added one more character, which means we are more zoomed into the world map, right? Now if you see here, for every cell we have 1H as the prefix, right? So the 1H is coming from one level higher, and the remaining character is added based on a calculation. So again, this was a 4 by 8 grid. So at each level we are dividing it into 32 cells, and then we go deeper and deeper like this, right? So there are multiple levels like this, and the deeper you go, the more granular is your world map. So this is the chart taken from Wikipedia, and you can see here that based on the length, as you keep on increasing the length of the geohash, which is that alphanumeric string, we are getting a kilometer error range, which means that for each level we can estimate a range of kilometers. So for level 1 we have plus or minus 2500 kilometers, for level 2 we have plus or minus 630 kilometers, and so on. And as you go deeper, we can go less than 1 kilometer or less than even 0.1 kilometer, and so on, right? So depending on your application's needs, you can choose the level of the geohash that you want to work with, right? So let me show you a demo about how this geohash system actually looks like on a real world map. So for this demo purpose, I'm using a GitHub link from this person, and it has been generated almost 10 years ago, and it still works, and it is very good for visualizing a geohash grid with Google Maps, right? So let's see, you can directly click this link and it opens a geohash grid like this, and we can actually visualize the different zoom levels that come with geohash, right? So this is the world map, and as you can see, I'm at the highest level of zoom, right? So I'm completely zoomed out. And at this level, we can see that there are alphabets assigned here, and there are exactly 32 grids like this. So each grid is assigned a character like N, P, 0, 1, 4, 5, and so on. So at the highest level, the world map is divided into 32 cells, right? So if I zoom in now, let's zoom into India. Now, if you see here, the map has updated to 2 characters. So every grid is having 2 characters, right? So if you think about it, all the prefixes will give you what level of zoom you are at, right? So if you see here on India, we can see that there is a prefix of T everywhere, and then there's one character added. So all the T's were the prefix coming from the higher level, and the new characters were coming from this level. And if I zoom in further, now you can see that there are 3 characters added. Now India has become larger, but now the characters have also become larger, which means that we are further zoomed in. Now you can see that every character has 2 prefixes before it. So you can see that T is having ET, W is having ET, TET, and so on, right? So you can go further down into this map. Now we have 4 characters, and you can see that map is getting bigger and bigger into Maharashtra, right? You can go deeper and deeper. Now we are seeing 5 characters. Now we are able to see 6 characters as well, right? So in this way, the map can be divided into subgrids depending on the level of granularity that we need, right? So this was a simple demo. I'll leave the link in the description for you to check out and play with, right? Now let's see how we can actually use this. So let's say we want to build a proximity service in one of our restaurant apps, right? So we want our users to be able to find nearby restaurants at any particular location. So here's what we have so far. So we are maintaining a restaurant table with ID, name, lat long information. And if we want to answer this question, get nearby restaurants from, let's say, a particular lat long. So you might be thinking of using some special geospatial database that works with range queries like this, but with the help of Geohash, you actually don't need to do that. So let's say we have this query, get restaurants from this particular location. So along with maintaining lat long, what we'll do is we will maintain the geohash of every particular restaurant like this, right? So we will add a new column called geohash, and it gives out some string depending on the granularity level we need, depending on the length of the prefix of the geohash, right? So once we have this, when we want to say get nearby restaurants from this one, what we'll do is we will actually get the geohash for this particular lat long with the level of granularity that we need. And once we have that, let's say we have the answer as 1ABC, and once we have that, we will get geohashes one level down with prefix 1ABC, right? This was at level 4. Now we want all the geohashes from level 5. So it will basically give out the next level's 32 grid cells, right? So we will have answer like this: 1ABC1, 1ABC2, up to 1ABCZ, let's say. We will get 32 geohashes. So once we have this, our query becomes really simple. We can use any simple SQL or MySQL with a like search, right? So we will simply say select star from restaurant, where the column geohash like 1ABC1, 1ABC2, and so on. And we will actually get the result, which was our restaurant in row 2, which was having a geohash 1ABCD. Now this has reduced from a complex geospatial query to a simple search query in any SQL or NoSQL database, right? So that's how geohashes can be effectively used in any proximity search location, right? So how do we get this number? So it is working on a calculation based on binary subdivision, where we are alternating between digits in latitude and longitude, and we are constructing this substring, and there's an algorithm for that. And almost all programming languages have libraries to support it, so we don't really have to worry about it. We just need to import the library and just say convert this lat long into geohash, right? So that's how we can use geohashes, and that's how geohashes can be helpful in system design. So whenever you're trying to design any proximity service which uses maps, so you can think about this as a possible solution, right? That's all I had for Geohash, guys. If you have any question, definitely let me know. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I will see you in the next one. Cheers.